Following the same idea, we will now focus on museum specimens and how to track them in publication by using bibliometrics. And so enhancing the museum data ecosystem, mining research publication for museum specimen will be the theme of Richard Naples' speech. Richard is data manager in the metadata and analytics department, part of Digital Project and Initiatives Division at Smithsonian Libraries and Archives.
Thank you. I will try not to speak too American, but I can't promise you anything. So today I'm talking about enhancing the museum data ecosystem through mining research specimens. And part of that is a question of what is the role of libraries in the museum data ecosystem? Like, what are we contributing as libraries and librarians? I'm going to talk about basically that idea of the two ecosystems working together. Then I'm going to talk about my participation in a mentorship program where we worked on data science in libraries. And finally, I'm going to talk about that project itself and the actual mining of publications for specimen data. So again, I'm Richard, and I work in the metadata department of the Smithsonian Libraries and Archives. And it is my focus is in scholarly communications and particularly tracking the research output of the Smithsonian and a bibliography. And part of my duties with that are producing research reports and bibliometric reports from that. And along with that, I get asked questions all the time about possibilities with that data. And one in particular has stuck with me over the time, and that was the question of whether it was possible to track museum specimens in publications. So, this came from somebody in our Natural History Museum, and they were wondering, is it possible to track specimens? And I thought about it, and at the time I was thinking the best way we could do that would be just to have a lot of people read through all the publications, find them, and track that. But obviously, like you, we have no people who can do that. We're strapped for time and money and resources. So it stuck with me over time, and I thought, what could we do about it? And so that's where, that's where this idea generated, and it stuck with me over time. So one of the leading purposes of, our collections in museums is the value that they provide to the world and society. But demonstrating that value can be difficult. And I know that, budgets are tight, and it's very hard to convince people. So I think, bibliometrics is one possible way of demonstrating the impact of collections through the research that's produced from their use. And of course, as library people and data people in general, we've built up an infrastructure to track that. Persistent identifiers, digital object identifiers, those sorts of things make it possible to track this data very easily. And while I would love for specimens to be part of that infrastructure of publications themselves, it's not that easy. It's a smaller part of the grand scholarly communications world. I don't think it's going to happen. So that leaves it to us, the question, is it possible to do this? And so I found my opportunity when I was presented by Martin Kalfaderick with the opportunity to work with Drexel University on a fellowship in data science and libraries. And the fellowship itself is in Philadelphia, and it was set up to improve data science skills in the library field. None of the people who do this fellowship have data science backgrounds, so they are new to this field, and they are often they're PhD students or early to mid-career librarians. And this fellowship is 18 different places from across the United States that participate, each hosting a fellow from Drexel. So with each of these fellowships, it's 6 months long. We had one in 2021, 2022 again, and we will have one this year. And the research question was put forth without any expectations of success of, is it possible to use data science techniques to identify and extract mentions of museum specimens from a set of publications. And again, this was new to everyone who was working on it, me included, so keep that in mind. Our first, so each of the fellowships, we had them work on the actual literature, do literature search, and then actually look at the produced research from the museum. And I also introduced them to people and, made sure that they had the resources they needed to do this. But also, I made a focus on the biological specimens in the Natural History Museum with the collection code USNM for the United States National Museum. So our first fellow came on board in 2021, and we worked on a subset of publications that we took from PubMed Central, which is from the National Institutes of Health in the United States, the library there. And it's completely open access, this subset. And it was also built with an XML format extracted already, using JATS, which made it easier to process. So we didn't have to work through that part of it. We could focus right on the processing. The trade-off was we could only get about 20% of things, of the publications that we hoped to do. So that was not perfect. And Ali worked through a named entity recognition process, natural language processing, where they trained a model through labeling specimens using a tool called Prodigy. And so that was identifying each of the specimen catalog numbers that were in a set of data that then was used to train a model to actually recognize it on a larger set of publications. And Ali was pretty successful. We weren't able to extract a lot of data. I think that the publications we worked from were from across the museums at the Smithsonian. We're 23 or 21 now, I think, and not everybody works with specimens in that way. But we were able to get some data, and I thought that was a good pilot to move forward from. So in the 2022 fellowship, we came on, Kat Forrest came along, and we actually joined forces with Andrea Tomer, who's a professor at the University of Arizona, working on this. And so we kind of joined forces to look at this together. They had a whole process already running to do this kind of activity. And so I thought it would be a great opportunity for my fellow to work with people who were, doing this as well. So we focused on all the zoology collections in our, in the Smithsonian, and specifically things in our digital repository. So they were all things that were open access that we've, had collected over the past 20 years, I think. And for this, we used a tool called Grobid to actually take the PDFs and splice them into sections. And from there, we could extract sentences and prepare the data. And with this, we used 3 approaches. The first approach was just using pattern recognition, which is a way to just identify, 4 letters, space, 5 numbers, that sort of pattern that would, identify the USNM specimens. So we did that. The second approach was a named entity recognition program. And with this one, we had to do a similar thing to what Ali did the first year, which is training a model by identifying, the specific set of human identified things in a publication, and then taking that and training a model and then testing it. The third approach we did was actually using GPT-3, which is ChatGPT. So this is a pre-trained Transformer 3, generative pre-trained Transformer 3. And so this is artificial intelligence that is not quite the same as before. You don't need a model to do this. It's trained on a large set of a humongous set of existing language. So it's supposed to make it so you do not need to train anything. And with this case, all we did, and actually was somebody from Andrea's lab who worked on this and not my fellow, so I just want to stipulate that. But we sent the sentences that we had extracted from publications to the API and just told it, can you identify the specimens in here? Just in in plain language, we asked that, and we got the results from there. And so this is just an overview of the workflows that we did. So with this, with the 2022 fellowship, the results we had for pattern matching, we were actually identified about 236 papers out of what we sent had specimen mentions, and of that there were about 2,600 individual specimens mentioned in their catalog numbers. And I ran a quick citation analysis on there and found they were cited about 5,800 times, so that's interesting. Now compare this with the next one, which is our named entity recognition results. And the one thing I want to point out, and maybe I'll quickly do this, is this one, if you look, it's much smaller here than it is the named entity recognition. And one of the things I think is going on is the named entity recognition, the model we trained, started identifying other specimens beyond the USNM specimens. So it was picking up that, plus other things that were not at all useful. We could run this data actually against GBIF download that we took and match a lot of things. And it was pretty equivalent what we were able to match exact between the two. But I did want to indicate that. And so to summarize the results, so far it looks like pattern matching is the best way to do this, but I don't feel like we're quite there determining how to best approach this. But we did run some scientific ways to measure the distance and that sort of thing. So we're going to continue the fellowship and work on that. I think it's up to the fellow to decide exactly how we're going to do it. And then we do have a grant to pursue this a little bit more. So I'm going to pivot. This is one of my favorite libraries quotes. It's from the introduction to Dante's Inferno that T.S. Eliot wrote. And that hell is a place where nothing connects to nothing. Because we have this data, what do we do with it? So beyond just refining this process and working on this and analyzing the results, the thing that I have a question about is what to do with this data once we extract it, once we are successful at producing this at scale, and where do we put it? I love Wikidata. That's a favorite place of mine. And I think, if you, there's a BHL white paper that was just released that speaks to this, that it's an important place for linked data. And this might be a great place to put this, to make it accessible, to link it between all the data sets. Of course, we could also share it internally through our database, or which would be great. The last question is, what would it take to make this data good enough to enter the actual museum systems that exist? Because there are questions about that. And I feel like this does speak to the idea of the digital extended specimen, and that it's more than just the physical specimen. There's more to it than just that. All of this data around it, enrich it. And I think of the Gestalt term, like the sum is greater than, or the whole is greater than the sum of the parts. So I do want to continue to work on this. And one of the reasons why is I think that the publications part is a rather, it's only one part of this larger digital specimen. And I do think it's important for librarians and the libraries to play this role in mining our own data to produce this, to help this, situation. So there are a few challenges left. One in particular I want to talk about is, the specimen catalog numbers, at least at our museum, are not unique. And so, multiple collections share the same catalog number. So when you're mining this data, you don't know exactly which specimen it is. And that is a challenge. Like, this is an actual one we found, and these are the collections, fishes, entomology, all over the place. But I'm interested in exploring how taxonomic names might help us along with this, and how we can join the data sources out there to see if we can produce good results. And so here's a question, can taxonomic names can help? And by golly, it's right in there. And so I can be pretty sure, I think, that this specimen here is for a shrimp. And so that's a possible way we could overcome some of these questions. So what remains? Obviously integrating the taxonomic data and figuring out how to work that together. Another big question is the idea of what set of publications can we start from? I used what I had available. It wasn't the primary focus for me or for my fellows. I wanted them to learn the skills and to work on that part. But extending it out, where could we go to make this actually useful for everyone? Because it needs to be a larger set of publications in order to do that. This corpus must be larger. So I think, BHL is an excellent place to start. Moving forward, we may have new ways of citing specimens in publications. I know that I've seen ARCs being used and actual URIs presented in the publications, but we have this whole corpus of, literature that is historic that will not be, changed to add that. And so we need to find a way to get that data out of there and make it available to people. Another question, I have is about the idea of the temporality of it, that collections change over time. And so we are looking at this legacy literature. How can we be sure that that actual specimen is the one that's in the collection now? So those are some questions. And obviously I want to look beyond our USNM collection. And even within the Smithsonian, we have many other collection codes in there, like US and Adam and H, and et cetera, et cetera. And of course, going back to the question of data provenance, like how can I make sure that this data is convincing to collections managers that they should include it with their systems? And so that's something I'm curious in how we overcome. So that's basically my presentation. Once you're able to connect the specimens to this literature in this way, I think that really opens up the possibilities for telling more stories about this data, about our collections, and about their impact on the world. And I do think that there are these tools available, they're coming online, they're maturing, and I think it's time to take advantage of them at a larger scale. And I think data should be interconnected at all times. And so I just want to give credits because I did very little of this work. And so this is our people involved in the project. And thank you very much. All right.